So for tonight, I thought I'd just carry on with the whole theme that I ended off with last time on the whole ex falso quodlibet. Um, and really, the main thing was just to speak about how future conditionals are really where the rub is when it comes to equivocation in that leads to absurdities that can be problematic um, when we're dealing with logic. So the main idea here is that um, when you're thinking of where absurdities can be introduced into sort of everyday speech, into sort of a regular speech, it's not really immediately obvious that somebody is going to construct an argument that is going to have an absurdity, and then they're going to do this whole thing where they have an introduction, a disjunction introduction, and then eliminate one of the terms. Um, it just seems a little bit mechanistic and implausible. Um, but one of the main ways where this causes a problem is with causality, and I've mentioned this before. Causality being a bit of a problem because causality uh, um, isn't exactly the same thing as the logical conditional, and the main issue there is that causality requires the constant conjunction. So, in other words, when I say that one thing causes another thing, as opposed to just one thing being correlated with another thing, when I say that one thing causes another thing, we expect the second thing to always happen as a result of the first. So, if rain causes wetness, if that causal relationship holds, rain must always cause wetness. Otherwise, rain doesn't cause wetness. Whatever that last step of the thing, so rain causes something, and that last little thing that actually causes the wetness is the thing that causes the wetness. So again, this one can think of causality in different sort of ways. But if we want to think about causality strictly, we need that constant conjunction, and this becomes a problem when we're talking about conditionals, because I used in the last video, I used the idea of my hand moving through water, causing a wave, which I said was fine, except we can construct, maybe artificially, but we can construct this sort of system where there's a wave going in sort of opposition, cancelling out exactly the wave that would have been caused by my hand. Again, not an easily constructed scenario, but a possible scenario. And this is problem. This is a problem because if we treat the causation as a if statement, then we have the problem where our if statement is true, just so long as whatever that thing that makes it false is not true. And so for us to have a good construction of reality based on an if statement like that, we actually need to beforehand figure out in detail exactly all of those conditions that might pertain that might make that thing not true. So if we really want to have a consistent if statement, conditional statement that doesn't violate logic in a way that leads to absurdity, that leads to this logical explosion, we have to be very careful in specifying all of those possible ways in which my hand moving through water does not generate a wave. Now, in that case, it might be a relatively simple one, but in general, as a general sort of rule, that's one of the main sort of challenges of science. So this is one way to think about how science is different from just establishing causality or causal statements. The science part is really in finding all those exceptions where it doesn't apply, because we want our causal statement not to cause this logical breakdown, essentially. And that's important from an engineering perspective, because the whole point is, if you have a scientific theory that works, you want to know precisely under which conditions it works. So from an engineer's perspective, this is something that very often I think gets confusing for people, is the engineering perspective of science, which is science which just works just reliably every single time, and that's fine. But from a scientist's perspective, it's the other way around, because from the scientist's perspective, you're looking at something that works every time around, and you're trying to get it to fail because you want to know where those failures are so that you can specify the theory more exactly. So that's the one way of thinking, and one could maybe call this the sort of the empiricist problem of science, the empirical. So empirical, like looking at the physical reality and seeing where does this theory that I've constructed, where does that break down? So that's the one side of it. The other side that we can think of it, and this is another way that equivocation can come into causal theories or scientific theories. The other way that we can look at it is we can say, okay, we can specify a statement a little bit more and say, just this next time that I put my hand in the water, because I've now looked at the thing and I've seen there's no mechanism that's going to create this contrary wave. I've measured the water, I've checked the air pressure, whatever, and I'm fairly certain that when I put my hand in that water now, it's going to create a wave. There's nothing that's going to stop it from happening. And so now we've got an if statement, and we can be fairly. So that's almost, if you think of the engineering sort of approach to it, you check all the conditions, and all the conditions are fine. You've checked all the boxes, and so now you can say, if I put my hand in the water now, it's going to cause a wave. Great. Problem is that if you really just analyze that statement, the moment you put your hand in the water, the statement refers to the future. So as I say, when I put my hand in the water now, perhaps I should maybe say that when I put my hand in the water in a couple of seconds time. So if we want to be precise about it, we're going to say in a couple of seconds, not now. So let's rephrase that. When I put my hand in the water in a couple of seconds time, it's going to cause a wave. So now it becomes more clear where the equivocation is, because when it actually comes to that point in time that I was referring to, that statement, when I put my hand in the water in a couple of seconds time, is now referring to a couple of seconds time from now. So in other words, your statement about the future effect, which might be true, always stays a statement of the future effect. You can't make a statement about now, because now is already in the past, the now that I was referring to. So that might seem slightly overwrought maybe, but from a logical point of view, when you try and create a rational basis for science, so now if we're sort of moving away from the empirical basis, we move to the rational basis of science, and these two bases are sort of like in almost constant conflict. So if we try to move to the rational basis of science, you want to have some sort of basis to have a strict statement that will always be true, and so those future conditionals just won't do, because you can't make a now statement in that sense. And so one of the main efforts that sort of, I mean, one could think of it as starting in the 19th century, but one of the main Enlightenment efforts, maybe one could even say, was to sort of discover a way to root conditional statements in some sort of really firm ground, such that you can say things, you can make that sort of conditional statement based on something really rational, and therefore build your science on logic rather than empiricism. This is a very, very important thing, because when we look at models used in science, those models are rational engines. They're not empirical engines, because they are built on logical principles. And computers, of course, are just logic machines. They can only affect the laws of logic. So all of the rules of logic, including the ex-falso quadruped, applies. And so really, if you want a model to work properly, what you want is you want to base that model on something that's fixed and firm. And that really is sort of one of the main themes of the Enlightenment project. And so moving on, in the next video, we'll start maybe just having a look at one of the main, well, at one of the sort of the first sort of real sincere or sort of deliberate attempts to get this going, and have a look at why it failed. And we've already got some clues that this might not turn out to be a successful endeavor. So we'll develop that a little bit, and hopefully in a couple of videos times it should be clear where we're headed with this. I don't want to give away the end of the story at this point, but but spoiler alert. Yeah, it's not going to turn out very well for that approach. So for now, the main takeaway here is just that equivocation especially becomes a problem with future conditionals, with statements about the future, which really don't have a truth value in the present. And this is a major philosophical and logical conundrum that turns out really can't be solved. So, okay, I think that's probably enough for tonight. Have a good one.